basically the exams. Thank you, Mohamed and Michael, and Charles for your confirmation. So basically, the exam will include material from chapter 1, 2, and 3 and 4. No, chapter 3 will not be covered. Okay. If not mistaken, I remember in our first class, I spent quite some time. Explaining what's the most important part for the entire class. Okay, so that is what's the root of all evil. I think you should know about the answer. Okay, it's data redundancy. Okay, this is why. This is why. Give me a second. It's redundancy. This is why we design the database. Okay, to remove data redundancy. So what you need to know, I want you to know, is that for modern database like Oracle, what are the advantages and then what are the disadvantages? Okay, what are disadvantages? So I think in the PowerPoint of the chapter 1, we spent quite some time walking through. Okay, I'm sure. Okay, I can record, this session. Yes. Okay. Let me turn on the recording app here at my laptop. Sawa, you cannot hear anything, but other people are hearing. Okay, I need to turn on. Sawa, can you hear right now? Is there any other people who's not hearing any sounds? Okay, so I need to turn on the software at my end to record. Anybody want to talk to me? Whose microphone is turning on? Haha. Okay. Okay, I'm turning on the software for recording. Give me just a second, All right. I record. I'm recording the using the WebEx function. But every time I record, I don't think you record anything. So it's kind of strange. I'm also going to record at my end using a software. Okay. All right, it's recording right now. It's recording right now. All right. Okay. So we'll see, which one work. Okay. All right. Thank you. So I think we also talk about in chapter 1 what's the two general approach for software development. The first one is SDLC software development cycle, which is also called waterfall, known as waterfall. Another one is the prototype approach. Okay, you can take a look at the slide, and then you need to know what's the one that we are using. for database development? Okay, the answer is the first one. It's the SDLC. It's the SDLC that we are using for this class. Okay, I haven't seen people using a prototype approach for database developments, but if you know about it, let me know. We just for all these years when I teach software database development, we always use SDLC. Okay, and I think it's quite understandable because most of you have learned about this methodology. I think the less important component for the for chapter 1 is about the 3 schema architecture. Okay, I explained about the first scheme. The first scheme is about the external. How does different departments, database users look at the database, and then you have to talk to these people, collect their views, look at the handbooks, the policies, the working documents, and then based on all those inputs, you develop a ER diagram. Okay, and then based on the ER diagram, you develop the internal scheme, and this is the foundation. This is the foundation, for relational model. Okay, that's chapter 4. That's chapter 4, and the SQL development. Okay. So these are the 3 schema architecture. I think you need to know about. I will have some question. Okay. So these are the key points for chapter 1. These are the areas. I have prepared some question for the first exams. I hope you can take a look and prepare yourself. Okay. Okay. So this is for chapter 1. Chapter 1 is the more foundational or more basic understanding. Okay, but it's technical. So let me switch the screen really quick. So to show you what is the three schema. Okay. So I'm going to share another application with you guys. I'm going to switch the application from, in just a second. I'm going to share the PowerPoints. Okay. Are you guys seeing the PowerPoint right now?
Yes, we can. Yes.
Okay. Okay. Thank you very much. So so these are the 3 schema. Okay, external schema, where you get input from all the users from different departments. Also look at the documents. If you're working as a consultant or developer, these are the information you want to get from different user groups. Okay, their documents. And based on those, you will synthesize the document and develop the conceptual schema. And this is where you develop the ER diagrams. That's for chapter 2. Okay, the ER diagram. And then this is for chapter 2. And then based on that, we're going to develop internal schema. And this is about chapter 4. Okay, chapter 4, the logical design. All right. So these are the 3 schema. I think you also need to know about this. So far, so good. Okay, thank you, Koman. Ashok, thank you. Okay. So I'm going to switch back to the Word documents for chapter 2. Okay, we're going to take a look at chapter 2. Can you now see the Word documents? I have switched to the Word document. Let me know once you see the Word document. Okay, not yet. Okay, not yet. No, no. Okay. Oh, okay. Let me do that. Okay. Yes, yes. Okay, yes. Yes, okay. Thank you. Thank you, Sawa. Thank you, Charles. Not sure. Now, thank you, Momet, Asita. Now, so for the chapter 2, okay, the most important part, are those basic elements. So what is entity and what is attributes and what's relationship. In entity, we have different kind of entities, right? We have strong entity, and then we have weak entity. We also have associate entities. You need to know what kind of a notation we use for strong, rectangular, weak entity, use a double line. For associate entity, we use rectangular, but the four corner is rounded. Okay, this is very important. I want you to use the right notations. And then we have, the second one is attributes. So attributes, then we have different kind of attribute. We have simple versus composites. Okay, like usually like address is composites, and then for simple like date of birth, uh, your just maybe like your phone number. Those are simple. Just a field contains one atomic value. Okay, and then we have single versus multi-valued. Single versus multi-values. Okay, we also have something else. I believe those are, for example, we also have the derived attributes. Derived attributes. Okay, so these are the things I want you to pay attention to. Okay, derived attribute, just for example. And the next big things about relationship. There are different kind of relationship, depends on the degree. There's a unary, binary, and ternary. And for any relationship, I want to see the verb at both sides. So one side is proactive, one side, the other side is passive. Say a student, for example, a student takes many courses. Okay, and then from the other side, a course, is taken by many students. So these kind of I want you to show verb at both sides, okay, of the relationship. So when you draw an ER diagram, I want to see this verb at both sides. And remember, there could be multiple relationship between two entities. Okay, I think you have seen this in your first homework. Okay, so you want to make sure you have this idea in your mind. There could be multiple relationship between two entities. Okay, all right. Followed by that, we also need to pay attention to cardinalities. So for cardinalities, there's mandatory.
This is Asita speaking. I do have a question. Do you know what is the proper way to properly identify the direction of this verb?
Yes, Asita, what is your question?
I was asking what is the key element to determine the direction of the verb? Because one is active and one is proactive.
Passive, yes. Yes, one is active, one is passive.
So how do we know the direction between the two?
Oh, okay. Just use common knowledge, common sense. So just use common sense. So as long as you put one side active, another side is passive, that's fine. Okay, I'm not too start, how do you call that? I'm not too paranoid about what is the right verb, okay, and then which side should be the active. I just want to make sure that one side is active, another one is passive. All right. Okay. Now about cardinality, we have mandatory versus optional, and then one versus many. Okay, this I want you to pay particular attention, because usually cardinality will determine whether a relationship is many to many. When it's many to many, you need to convert that to associate entity. Okay, so this is quite important. That is why I want you to pay attention to about cardinality. Later on, I will. And the final, or probably the most difficult parts, for chapter 2 is about associate entity. Associate entity, okay. And I remember I have shared this with you. I have summarized that there are four conditions. There are four conditions that you should use. You should think about converting a relationship into an associate entity. The first one is that whenever you see a many-to-many relationship, okay, whenever you see a many-to-many relationship, without question, just convert that into associate entity. You cannot be wrong. But the key is that how can you know it is a many-to-many relationship? The answer lies in the cardinality. Cardinality is the key that help you determine whether a relationship is many-to-many. That is why I want you to pay some attention about the cardinality, whether it's mandatory, optional, and then whether it's one versus many. Okay, the many part is probably the most important. Will help you determine whether it's associate entity. Okay. Okay, then Michael, I'll come back to weak entity later, okay? I see your question about weak entity. Once I finish about associate entity, I go back to weak entity. Thank you. And then the second situation that you will convert a relationship into associate entity is that when a relationship has its own attributes, okay? That means it has its own life. It has its own life. So that's why you need to make an associate entity. So, this is the second situation you want to convert a relationship into associate entity. I'll show you a diagram later. Okay. And the third situation is that whenever it's a ternary relationship, whenever it's ternary or higher level quadratic, or hexagon, pentagon, where you have 5 entities have a relationship together, which I never seen before. Okay, you need to convert this into associate entity. Okay, a final situation is that whenever you have a time-stamped relationship, you need to convert that into associate entity. Right. So these are the 4 scenarios. Whenever you see that, you need to convert that into associate entity. The more challenging one for, the way I see the more challenging one is this one. Okay. Whenever you have, oh, I'm sorry. Yes. Okay. A many-to-many relationship. All right. So to better illustrate this one, I want to go back to the PowerPoints. The PowerPoints for chapter 2, part 1, ER diagrams. All right. Part 2, I think it's part 2. In a second, I'm going to open the file, part 2 of chapter 2, part 2 of chapter 2. In just a second. Okay. And I'm sharing that file with you right now. You should see the switch to the Microsoft PowerPoint. Okay, okay, you are seeing the PowerPoint right now. It's chapter 2, part 2, right? Okay, timestamps. Yes, Asita, I give you example about timestamps. Okay, so so there are okay, I'm going to slides. I think slide 22 right now. Can you guys see it? Slide 22. Can you let me know if you are seeing slide 22? Okay, thank you. Okay, so the first scenario, we want to convert relationship into a many-to-many relationship. Is when you see a many-to-many relationship. In these cases, like a student can take many course. A course can be taken by many students. All right. So whenever you see this kind of cardinality, a many-to-many relationship. Okay. Regardless, it's mandatory or optional. Whenever you see many-to-many, you just convert this into an associate entity. Okay. And when you convert this to associate entity, okay, these are the magic I showed you before. It's a multiple step. It's a multiple step. First, as I shared with Asita earlier, is that you have verb, at both sides of a relationship, and then once you figure out, it's a many-to-many relationship, you create an associate entity in the middle. Associate entity in the middle, okay? And then remember that you use a rounded corner, okay? You don't use a sharp corner. You use a rounded corner for associate entity. And then the next step is that we need to determine how to move the cardinality about the two relationship right here on the right hand side and the left hand side. Okay, I'm going to shift to next slide, 26. So you moved cardinality in the left hand side to the right hand side of the associate entity. Okay, that's the first step. And then you move the cardinality on the right hand side of the relationship to the left hand side of the associate entity. All right. And we are not done yet. We still need to take one more step. That is, make sure it's mandatory once on both sides. Okay. The rationale is that the rationale for our having this way of modeling is that, so when I look at from the left hand side to the right hand side, employees can take many courses. When I look at the relationship from right hand side to the left hand side, is that a course can be taken by many employees. So what I have right here in the middle and then the associate entity, the key purpose of having this associate entity is to know, like a registry, to know which employee has taken what course. and that's the composite primary key right here. So for each record in a social entity, I need to have one and only one course. I need to have one and only one employees. That's why on the left hand side I have the mandatory one, and on the right hand side I have this mandatory one as well. Because for each records of the social entity, I have one course and I have one employee. Okay, this is why we have the this is why we have the cardinality as such on both sides. Okay, so this is the four-step magic you need to remember whenever you create an social entity that involves a many-to-many relationship that result from this many-to-many relationship. These are the four steps you need to have. First, create a social entity, and then the second step, give me a second.
I do have
The second,
no,
give me a second. Give me a second, okay? Have a social entity in the middle, and then move the blue side, to the right. Give me I want to remove everything. Okay, move the cardinality on the left-hand side to the right-hand side. And then the next line, move the cardinality on the right-hand side to the left-hand side of the social entity. And then finally, okay, you create this mandatory one for both sides. All right. Sorry, I missed your question. Was that Asita again?
Yes, it was me.
Okay, please.
The associate entity. The associate entity
Yes.
include only the composite primary key, or it can have something else.
It can have something else. It can have something else. Okay. So for instance, no, it can have something else. So let me, for example, let me give you one example. So I can add one more instance right here. Say I can add the dates of the class. So let me give you one example. Okay, I'm going to do this again. Hopefully this time works. I can have, dates. Dates of, of class, and I can also have, completion dates. I can have, the certificate number. Okay, I can have a lot of things. All right, no problem. You can have many other attributes, that you need to have. That's fine. Okay, because it's like a new entity. You can but it depends on the needs. If you really have something important records, maybe you can also have the grades, for the class that taken by these specific students. That's fine. Okay, so like case right here, here for example, we have this. Okay, we have, and then I can. Another example is that you can also, other than the primary key, composite primary key, what you can also do is that you may create, and like this one right here, I can create a primary key of its own. So right here, rather than using the course ID and then the employee ID as a composite primary key, I can create a new primary key called a certificate number. Because it's a unique number, no two certificates will have the same number. No, so it's like a VIN number and then social security number. I can use this one as a primary key. So this is an alternative to model a many-to-many relationship. Okay, so far so good, guys. Okay, great, excellent, excellent. Now, okay, sometimes we need to name the social entity. Is there any proper way to do that? Great question, Asita. Great question. So Asita is asking, what's the right way to name the social entity? Okay, like this one. It doesn't really matter to me. For the social entity, it doesn't really matter. You can name these, as you can name the social entity. For example, I can name it as certificates, okay, or I can name it as employee and course. As long as this is a noun, that's fine. Just make sure it's a noun. All right? Does that make sense to you? All right, all right. Thank you. That's a great question. So I'm going to the next slide. The next slide. In the third situation is that, whenever we have a ternary relationship or high-level relationship, do not even think about it. Just automatically convert that into a social entity. Okay? So like situation right here, we have a part shipped to by a vendor to a certain warehouse, just create a social entity. Okay? And then the next one is a timestamp. The timestamp attributes. A timestamp attributes like this. Okay. So so we have this is an entity called products, and then we have the product ID. This is the primary key. The primary key is the product ID. That's why it's underlined. And then we have an attribute. We have attribute. It consists of two entities. One is called the effective dates, and then we have price. So it looks like this. We have this. For the product, it's $100 on January 1st. It's $80 on March 1st, and then it's $150 on May 30th. So it's a multi-values. Whenever you see a multi-value attributes, you should think about converting these into a social entity. Okay. I think that's the right way to do that. Think about converting this into a social entity. And that is why, whenever we see timestamped, the timestamped, it must be a composite and then a multi-values. Whenever you see a multi-value attribute, convert that into a social entity. Okay. So these are the 4 scenarios. We will have this, have a relationship or something or attribute convert into a social entity. Moment has left. All right. So here on slide 41, here we have the example that you can see two. Well, this one I will not test. This is too complicated. It's called the bill of material. Don't worry about this. I will not test this in the exams. You don't have to worry about this. You don't have to worry about it. Okay. So these are all the things I will test in chapter 2. So I will strongly encourage you to practice those questions where I've already sent you the answers for chapter 2. Those questions are in the end of the textbook of chapter 2. Practicing those questions and then compare those with the answers will be very, very helpful. Okay. So far, so good. Okay, okay, great, great, great. So let me see. We can go to. I'm sharing the Word file. Can you see the Word file right now? Okay, great. Thank you. Yes, yes, thank you. So chapter 4, is primarily talking about the relational model. Okay, relational model, and then data normalization. I think these are key things you need to know about. So it's what you need to do is to understand how to convert from chapter 2's ER diagram to the relational model in chapter 4. Okay, so these are the key things. The first and most important thing is to understand what are the requirements for a relation. So in what conditions can a table qualify, as a relation? So I'm going to go to slide on chapter 4. I'm going to slide chapter 4. I think slide part 1. Just a second. I'm going to close the slide. Oops. Okay, I'm going to open the slide for chapter 4, part 1. Okay. So I'm now on slide, here, slide 4 here. Basically, based on what we have on ER diagrams, I want you to convert into this kind of a relational model. In a relational model, we put everything about entity into the like this kind of headers, the first row. I'm in the slide 4 right now. Can you guys see this?
It's a gray screen.
Oh, you cannot see that. Okay, thank you for letting me know. Oh, because I closed the PowerPoint file. I need to share that again. Okay, that's a rule in the WebEx. Okay, can you see that right now? PowerPoint slide, page number 4. Okay, thank you, Coleman. Always first to let me know. Thank you. So here in that we have converted. Now this is like the first row of the Excel file. Okay, and this is what we need to achieve. We need to convert each entity from ER diagram into this kind of a model, relational model, where we see every attribute's been break down. There's no composite attributes. Everything is single and simple. Okay, so the address has been break down into address, city, state, and postcode. It's not composite anymore. And then we need to also, like ER diagram, we need to underline which one is the primary key. We also need to underline using a dash line, what's the foreign key. Okay. So we need to know what's the foreign key and primary key. And we also need to know from the primary key, where does it point back to? Okay, I use the analogy. This like a baby. It has the DNA from the father's side and has the DNA from the mother's side. Okay, so these are like order, and then the product. They are the parents of the order line entity. Okay, so I have the DNA from both my mom and my dad. And in the overline case, the DNA from my mom and my dad, they are both my composite primary key and they are my foreign key. Okay, so these are the this kind of diagram. The entire diagram is called a relational model. Okay, this is what we need to create for chapter 4 because this is a foundation for chapter 6 and 7. Once we have this one, we can develop the database. Okay, so this is what you need to know. And then all the contents in this chapter is about how to convert the, why do we need this kind of diagrams, the relational diagrams, and how can we convert the diagram from chapter 2 into these models, relational model in chapter 4. Okay. All right. So another key things. So these are field diagrams that you can take a look by yourself. How to convert that into from this kind of entity into this kind of relations, okay, and what's the attributes. This is called a relation. Sometimes we call it table, we also call it entity, but we use this term interchangeably. Okay. All right. So I need to go back to the Word documents. I'm switching back to the Word documents right now. Let me know when you can see that. Okay. Let me change the Word documents. So this is Word documents. So the next question is that, what's the requirements for relations? Okay, there are quite a few requirements. Okay. I think the slide, what's the slide we talk about it? What's the requirement for relation? Okay, on the slide, page 2. Can you see this? Can you guys let me know once you see page 2 of the slides? PowerPoint, page 2. Okay, thank you, Dahin. Okay, you got a first row this time. All right. Okay, thank you, Charles, Asita, Dahin, and Coleman, Sarah. Okay, so the requirements and so on. The requirement for relations, okay, or the first normal form. When you are in the first normal form, that means your table, comply with requirements for a relation. At least the table name must be unique. So the name of the entity must be unique. There should be no two tables, no two relation, or two entity have the same name. I think this is quite straightforward, okay? And then, the most important part is that no attribute values, no attribute in a first normal form or in a relation, okay, should be multi-valued. No attribute should be composites. If you in a first normal form or a table can be called as a relation, okay, these two are equivalent. All relations are in the first normal form. When you have a table that's a good relations, that means everything in this table need to be atomic. Need to be atomic. No multi-values, no composites. This is very important, okay? This is very important, so I hope you can pay attention to. All right. And the attributes in the column must have unique names. So no two attribute or no two column should have the same name. Okay, I don't want to have an attribute called last name and then another attribute also called last name. That will confuse me or create redundant data. I don't want to have two attributes that are the same. Likewise, I don't have two rows. I don't want to have two rows that have exactly the same values. So I don't want to have two records that showing the name is called JJ, have ID 12345, had a birthday on January 1, 1970. Okay, no two rows should have exactly the same values. Otherwise, I'm creating redundant data. So this is important. Okay, so the row, the names, the tables, the records, the columns, they should all be unique, okay? And then attribute value should be atomic. And there are two things that should be, that should be irrelevant. That's the order of the column and then the order of the rows. It should be irrelevant. The first row can be first name and then last name and then the ID, okay? Or I can starting with the first, the column as a first name and then ID and then last name. It does not matter because you can always change the sequence of your column, okay? In whatever sequence you like. Likewise, for the sequence of the rows of the record doesn't matter. You can want to start with male student first and followed by female. You can start, the student with the youngest, the smallest age, followed by a higher age. Okay, the highest GPA, then the lower GPA. It does not matter. You can sort the data any way you like. That's why the order of the columns and then the rows are irrelevant. Okay? So this is very, very important. This is very important, is that you need to know what's the requirement for a table to be qualified as a relation, okay, or for a table to qualify as a first normal form. This is very important. This is very, very important. Okay, so I need to switch back. Are you comfortable right here? Any question for what's the requirement for relations? Any question? So I'm switching back to the Word documents. Okay, I am now, I want to discuss about the three types of anomalies. There are three types of anomalies. Okay, and this is why, these are the reasons we want to normalize the data. Okay, these are motivation for data normalization. So before, these are three reasons we want to normalize the data. These are three kind of anomalies. Okay, insertion anomaly, and modification anomaly. Quick go over these answers, these anomalies right here, but I suggest also take a look at the textbook. Okay, so let me switch to the PowerPoints and talk about these anomalies. All right. Oh, sorry about that. My mistake. Okay. Before I move to an anomaly, okay, I hope to show you more slides about how to convert ER diagrams into the relational model. Okay. Okay. So let me just remove all the. Okay, I'm going to the next slide. Slide number 8. Okay, these convert simple ER diagrams into simple relations. Okay, slide number 9. Here we have a composites attributes, address. You need to break them down into a simple attributes right here. Okay. Okay. If you have any question, just let me know. Okay, I'm going to slide number 11. So here, then Michael, you have a question about what is a weak entity. So this is a weak entity, right? So here I have a strong entity called the employee. Think about this is as me, JJ, the professors or faculty members in Georgia State. Okay. But here I also have an entity called the dependence, and it's a weak entity. Why do I call this as a weak entity? The reason I'm calling this a weak entity, you can think about this is like my wife and then my children's. Okay, I need to have this information about my wife and my children so they can use my insurance in Georgia State. So these are my dependents. The reason it's called a weak entity is that if JJ, quits or finish my job, my contract here in Georgia State, and I disappear from the database from Georgia State, then my wife and my children, they will also automatically disappear from the database because their existence depends on my existence. Okay? Then Michael, are you here? Is there Michael? Oh, can someone, okay. Basu, thank you for confirmation. Okay. Just let them Michael know about that. So once I remove the records, in the primary or the strong entity, the dependents, like my wife and my children in this weak entity, will also be removed. All right. So how do I convert ER diagram of this kind, a social entity, a weak entity, and a strong entity into a relational model? Okay. Maybe Pasu, can you share with him later, with them, Michael? Okay. Pasu, can you share with him later, and then I'll count that toward your contribution. Okay. So that I don't have to repeat to everyone else, because you guys have heard about it. Okay. And then Michael just talk to Pasu. I have shared the example with him. Okay. About what's the example of weak entity. Yes. Okay. So how can I convert this kind of a weak relationship, identify relationship, and then so this is the page 12 is a solution. So you have this information about the weak entities. These are the partial identifier, and then you plus the primary key. You plus the primary key from the strong entity. So these four, they are forming the composite primary key. These four are forming the composite primary key, and then for the weak entity, and then this one, the foreign key, can trace back to the parents. Okay. So, and then this is a one-to-many relationship in the slide 14. I'm in slide 14 right now. Okay, can you see that, slide 14? Okay, slide 14. And then for slide 15, slide 15, this is the nurse care center example. Okay, you want to take a look, at this one. I think I have a couple of questions. About the nurse and the care center. I want you to think about, when you have this one-to-one relationship, and it's mandatory on one side and then optional on the other side. How should you decide whether I should put the nurse ID, into care center as a foreign key, or should I put a center ID into here, a nurse side as a foreign key? Okay. The answer is in the next page, slide 16. So I think you can think about it. I believe spend quite some time, explaining the relationship right here. So slide 18 is about a social entity. How can you convert that? We have seen that before. The answer is on slide 19. Okay, this is kind of simple. And then, we can also I think this is same. Slide 23. Also a social entity, but you don't use a composite primary key. You create a simple primary key. This is another way to express a composite social entity. All right. Finally, we have a multi-valued attributes. Whenever you see a multi-value attributes, you think about a social entity. Okay. And then here on slide 26 show you how to do that. So I have an entity called employee. So I create an employee entity on the left-hand side, and then I have a multi-value attribute. It's called skill. So I have this one, that one as a single table right here. Okay, single entities. To record, which employee have what kind of skill, I have this social entity. Recording the primary key and then non-primary key. These two are composite primary key, employee ID. So when I convert this into a relational model, this is how you do that. I have a table called the employee. I have a table, called a relation called a table called the skill, and then I have a social entity, like my children's of the parents. Okay, linking back to the father side, and then the mother side. Okay. So this is important. I want you to pay attention to this one. Okay. Whenever you see a multi-value attribute, think about an associate entity. All right. We are almost done. Whenever you see a ternary relationship, convert that into a associate entity. Ternary relationship, associate entity. And then this is a unique sample. I have repeated several times. I have a physician prescribe the same treatments to a patient several times on the same dates. Okay, so in this case, I can use 5 attributes as a composite primary key. Okay, or alternatively, I can create a new attributes. I create a new attributes called the treatment number, and here as primary key. In this case, patient ID can be a social entity, physician can be a social entity, treatment code can be a social entity, and treatment time and day can only be regular entities. And these are 3 foreign keys tracing back to the parents. All right. Okay, I'm sorry, it has been going on for 1 hour. At this moment, I believe I should give you guys a break. Okay, it's healthier if I give you guys a break. Let's take a 12 minutes break and then come back at the 11 o'clock. Okay, go to the restroom, have a cup of drink, coffee, water. Slide 19 and then slide 20. We also have this anomaly, show in instance example another time. You can take a look by yourself. Okay. So I want to switch to the Word document now. So the critical components for chapter 4 is about data normalization. Okay. And in the data normalization, one thing you need to know about is about, draw the functional dependency. Drawing the functional dependency. So we have talked about, how to convert a table that's not in the first normal form, convert that into a first normal form. So the solution is repeating, the value and then fill out the blank area. So that's, what we just talked about. But then, the next step is to the functional dependency, and then followed by second normal form, and then the third normal form. So I'm shifting to the PowerPoint to show you the diagrams. This will be easier. So I am in slide 23 for the second part of chapter 4. So in slide 23, in the exam, I'll let you know which are the composite primary key, like order ID, like the product ID right here. These are the composite primary key. I show you that, okay? But what we'll ask you to do is that I want you to draw all these functional dependencies, whether it's full dependency, partial dependency, or transitive dependency. We spent about 1.5 hours last week explaining what is a full dependency, partial dependency, and transitive dependency. I'll say it one more time, okay? For full dependency is that, you have a composite primary key, and then the value of an attribute, say order quantity, is co-determinant. Is co-determined by both composite primary key. So to determine the order quantity, I need to know which order and then which product. I need the value of both of them to know, what's the value of order quantity. So for order quantity, it's called a full dependency because I need both the value of both primary keys so I can determine the value, okay? However, for other attributes, like order date, customer ID, customer name, customer address, I only need to know one of the two composite primary keys. They are order ID and product ID. I only need one of them. I can determine the value for the rest. So, but I don't need product ID. I only need order ID. I can know the date, customer ID, name, and address. So like this one. I need order ID to determine customer ID, customer name, and then customer address. And in this case, it's called partial dependency because I only need part of the composite primary key. It's called a partial dependence. Likewise, for product descriptions, product finish, product standard price, product description, product finish, and standard price, I only need product ID. So I only need part of the composite primary key. I can determine the value of these three attributes. That's why this is also called a partial dependency. Partial dependency. Okay? That's why it's called partial dependency. Whenever we have the partial dependency, we are not in the second normal form. Whenever we have a partial dependency, we are not in the second normal form. What's the solution to address partial dependency? Can someone answer me? What's the solution to solve this partial dependency so the table can become the second normal form? Can someone answer me? Anybody have solution? Yes. 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 Thank you, Asita. Thank you, Aman. Yes. Masu, the answer is yes. Okay. So the solution is to break down the one that has a partial dependency, and then the one has a full dependency, make it a social entity, like this one here. The one has partial dependency, make it one table, and then for order, create another table. So we have three tables right here. Order ID, product ID, and then the order line, okay? Order line use a composite primary key, order line and products. So order line will trace to one of the parents, and then the product ID will help you trace back to another parent. So one of the relationship right here represents one of partial dependency. Another one represents another partial dependency. Okay? So in this case, when we have no partial dependency, we are in the second normal form. So figure 428, once you don't have any partial dependency, you are in the second normal form. You are in the second normal form. So let me back to, to the slide 23. But still, there's another dependency. That's called a transitive dependency. That is, some of attribute like customer name and the address is determined by another attribute that is not, of the key. Customer ID is not a primary key, it's not a composite primary key, it's not anything. It's just a non-key attribute. However, it also determines the value of other attributes. So in this case, we have the so-called the transitive dependency. The reason it's called a transitive because order ID determines customer ID, and customer ID then determines the others. That's why it's called a transitive. The reason, again, is transitive because this is kind of transitive. Order ID can determine customer name and address. However, there's something, customer ID is a mediator that's mediating the order ID's value and determining what's the customer name and address. So let me move to table slide 24. If your table, after breaking down, the social entity and then the partial dependencies, okay, we still have this transitive dependency in the third table. Whenever your relational model still have transitive dependency, you are not in the third normal form. So when you have transitive dependency, what's the solution? Okay, guys, what's the solution right now? How can I address transitive dependency? Can someone answer me? Whenever you have these, yes, break it down, separate the table, exactly. So whenever you have this transdependency, you go to, you break it down further, like this one. So from slide 26, we have transdependency, and we can move to this is not in the third normal form because we still have transdependency. You can move the transdependency by separating that into another table, right? In this way, we don't have partial dependency, everything's in the third normal form. And everything can trace back to their parents. Order ID, product ID, and customer ID. Okay, these are the foreign keys. Okay, now we are in the third normal form. So far, so good. Thank you, thank you, thank you, thank you. Okay, thank you. So, so whoever left, I can tell you is that's one. I have give you two examples to practice about data normalizations, and then in each of the example I give you what's a primary key. I've shown you, the first one is about this student course, student course, and then the grade, instructor example. Okay, I give you what's the primary key is a course ID, and then the student ID asks you, whether this is the first normal form, what's the problem, this is what's structured, and then what's the solutions, filling out the blank by repeating the values, okay? And then I'll ask you to draw the functional dependency. You need to draw the functional dependency. I want you to see all these arrows. I want you to draw this functional dependency. And then, you will tell me how can you convert that into a second normal form. And after you convert to the second normal form, I ask you to first identify if there's any, transitive dependency. Like in the second normal form, we still have this transitive dependency because once I know the name of the structure, I can know this phone number. All right? So we need to convert that into a third normal form. This is one exercise. And then we have another exercise. It's about a property. I think this is from our, from the last class about property rental. Okay, I also identify the primary keys and then property number, client number, and then ask you to tell me whether what's the problem right here. You see it's in the first normal form, and if not, what's the solutions? And then again, I want you to draw the functional dependencies. This is the partial dependency, full dependency, partial dependencies, and then ask you to convert that into a relational model. And then you tell me, if there's anything else, like transitive dependency. Give me a second. And then if there's any transitive dependency like this one, okay, owner number can tell me the owner names. How can I solve the problems? Just by break it down further. All right. Okay. So far, so good. Great. Thank you. Thank you. So, so this is basically what you need to know about the exams. Again, I strongly encourage you to read the textbook, practice the problems, and then compare your answers with the keys I share with you later for chapter 2 and 4, which will be helpful. Okay, so right now I'm going to start recording here. I want to shift the gear to something else. Before I do so, before I start recording right here, do you have any question for me? Okay, so I recognize that and you are comfortable with what I mentioned. I'm not done yet. Okay, yes. The exam, I have sent the Asita. I have sent a Word document to everyone. I have sent a document to everybody. I can send you the one again, with my color notes. Okay, I can send that. Yes, the exam was starting at 9:30 sharp, 9:30 a.m. sharp. Okay, right away. You need to be there earlier. You need to be there earlier because the exam will stop at 12 o'clock sharp. So it's for your own benefits that you be there on time and start on time. No, milestone 3 will not be due next Friday. There's nothing due next Friday. Only thing due next Friday is the exam. Just come here and take the exams. Milestone 3 won't be. I'm not sure. I mentioned that. Did I put that in the syllabus? Oh, let me check. Let me check the syllabus. So if that's the case, Yeah, let me take a look. Give me just a second. Syllabus. For the syllabus, I'm not sure. Oh, okay. There's nothing due, in terms of the. Give me a second. Nothing due, for milestone 3. I think probably in the case description. Milestone 3, let's follow the syllabus. Milestone 3 will not be due until November 1st. Yes. Milestone 3 is due on November 1st. Is that okay? Guys? Okay. Yes. Milestone 3 is due on November 1st. So this week, the only thing you need to worry about, worry about is milestone, it's the exam. Okay, it's the exam. All right. So stop recording of the exam, the review for the exams. Now, for the following few minutes, we still have some times. I want to go over the answer for the milestone 2. Oh, okay. Yes. I'm going to go over the answer for milestone 2. Give me just a second. Hey, Payel. Then Michael. As long as you here today, I count out toward your quiz. Okay, 100% for your quiz. But it's not the same. Okay. So Payel, can you check has everything submit their milestone 2? And let me know. You can send me the text message through chat.
Okay, I'll send it.
Can you let me know the answer? Payel? Oh, okay. Oh, you send me the text message. I mean, has everybody sent it? Everything?
Yeah.
Yes, yeah. Okay, great. Okay, great. All right. So, guys, I'm sharing the result with you because I think it's kind of important. You need this. You need this knowledge for the second exam, and then for the for the milestone 3. Okay. Can you see the? Oh, I have to share the PowerPoint with you. Okay, I'm sharing the PDF file with you guys. Oh, do I have the PowerPoint file? Yes, I have that. Can you see the PowerPoint file? It's the answer for Research Carter Research Institute. Okay, thank you, Sawa. Now you are the first one. Oh, yes. Aman, thank you. So I think this is critical. There are few simple, or simple entities which are, for example, donor type, and then also the committee members. You can use a different name. I don't mind. Programs and then campus. These are just some very simple entities. Okay, and there are associate entities like contributions. Payel, if they make this one as a regular entity, that's fine. Okay, because contribution is kind of unique. Okay, if they put this one as a regular entity, it's fine. If they put this as a social entity, it's also fine. Okay, and then this one connects, connects programs, connects donor, also a committee. So basically, is that whenever a donor contribute the money, we need to record which program the money goes to, and then what's the committee member who advise or handle this contribution, specific contribution. So that's about this associate entity right here. Okay, that's one key thing, and there are about 4 other attributes and associate entity, because the relationship is kind of many to many, like campus and then the programs, because each program can be can belongs to several different campus, and each campus can include many different kind of program. So they have this many to many relationship. So we have this social entity right here, capturing this kind of a many to many relationship between program and campus. Likewise, committee member, they have this kind of also many relationship with the programs. A committee member can handle many different kind of program, and program can be handled by many different committees. So they also have this kind of many-to-many relationship. That's why we have this social entity in the middle, capturing this many-to-many relationship. For the same, for the same logic, member donor is to capture this kind of a relationship between donor and the committee member. And the one that I have right here, member donor type, is to capture this man-to-man relationship between donor type and then the committee member. Okay. One thing I would like to clarify is that, not clarify, we have donor type. There are 3 types of donors, right? And then, each donor type can include many donors under that category. So we have this kind of a relationship right here. And then another interesting relationship we want to point out is that a donor can be contacted by a certain members, committee members. That's why we have these social entities. Okay, and each donor can be contacted by multiple committee member, and then each committee member can contact multiple donors. That's why it's a social entity right here. However, when a donor donate a money, a specific amount of money contributes, that's serve as a contributions, it can be handled or advised by another committee member. Okay, that's pointed out in the case. That's why these two relationship is represented by 2 separate lines. Okay, this is kind of a this is a nuance in the case. This is very subtle nuance. Okay, I want to point out to you. All right, so this is the right answer for the case. This is the right ER diagrams. Other interesting thing that you want to pay attention to is that whether there's a composite primary key, you need to underline several attributes like here, composite primary key for the associate attribute entities right here. Okay, composite primary keys. Okay, these are something special. And there's another thing also interesting. It's about quarterly targets. It's a multi-valued attribute. It's a multi-valued attribute for committee member, for campus, also for donor type. Okay. So these parts, okay, I'm not sure all of you, successfully captured this, because this is really the first time a multi-value attributes. It's really a composite attributes. It talks about, for example, for a specific campus. Now, let me give you one example. Okay, so for a specific campus, there's east, south, north, and west. For each year, for each quarter, I have a specific amount, that serve as my quarterly targets. And for the 4 campus, for every year, every quarter, I have a specific amount. So for the same campus, in a certain year, I have 4 quarters. For each quarter, you have to tell me what's the amount. Then that's your quarterly targets. So this is really like a multi-valued attributes. Your team may not be correct on this one, okay, which is fine. Don't criticize yourself. Don't criticize yourself. But this is the subtlety or the something more advanced I want you to learn about. And your milestone 3. In your milestone 3, I will ask for the relational model. That's basically chapter 4. I'll ask you, based on these ER diagrams, how can you draw a correct relational model? That's your milestone 3. You don't have to think about the answer right now, okay? But I think you have to understand this ER diagram. This ER diagram has multiple purpose. The first is that I'm telling you the ER diagram, so you can learn from here, and this knowledge will help you to answer the questions in the first exam. Okay, you need this knowledge for the first exam. And then you need this knowledge to correct your ER diagrams for your milestone 2. Third, you also need this knowledge to answer your milestone 3, to draw the relational model. Okay. So I will share this diagram with you all, and then you can learn from here. Do that today, so you have something you can compare now with your answers. So you can learn from here, and the knowledge that you gain from here will be applied to the second exam, the first exam. Okay. Thank you, Armand. All right. Any questions so far? No? Great. Great. Okay. So, I think this concludes our exam, our review for today. Also, my answer to your milestone 2 for the team project. I hope you still have 1 week, to review. You have to be there in person for the first exam. You must be there also for the second exams. It's gonna be the classroom 100 in RCB buildings. Okay, bring pencil, bring erasers. All right. Scantrons. What is scantrons? Ahmad, what is scantron? No, I don't know what is that. Can you elaborate? It's like scanner view. No, it's not a Bobby. It's not a Bobby sheet. No, 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 no. I give you some exam papers. Answer sheets. You only need to fill in. There's no bubble in the test paper. Don't worry about that. Yes. No bubbles. I will just give you some question, multiple choice, and true, false, and then you will tell me about A, B, C, or D. In the answer sheets. Also, you will draw the ER diagram, relational models, and some short answers in the answer sheet for the short case. That's it. But bring eraser, bring pencil, okay? Pencil and eraser. No. You will. How many questions? I don't remember, but you have enough time. How many questions? 50 questions, maybe 50, 55 questions in total. Yes. All right. Yeah. Most students, can finish that in time. So, yeah, that's my observation. Okay. Any other questions? What is? Okay. Give me just a second. Give me just a second. No. Apparently, I do not understand. No scantron. Yes, Harry. Thank you, Harry. No scantron. Yes. Don't bring any scantron. Okay. Yes. Not for my class. Okay. I think I used scantron before. Who's talking? I'm sorry, who's talking? You were speaking very quick. Can you speak slower?
Yeah, I'm really sorry, Professor. I was not on mute. I'm sorry.
Oh, was
got
that
a call
Indian?
from home. I'm so sorry.
It must be your roommates. Okay,
Yeah, I'm so
that's
sorry.
that's another language. I figured that. Don't worry about it.
Yeah.
So, no, I don't understand Indian well, enough. So yes.
That's okay. That's okay.
Okay, that doesn't matter. Okay, I saw you were talking to me. Okay, all right. Okay, guys. If no further question, I think that's it for today's. And I wish you have a good weekend. Start the review as soon as possible. That will make your life easier. Okay. Have a great weekend, Cyrus. Have a great weekend, Coleman. Thank you, guys. Thank you, guys. Thank you, Sarah, Azama, Asita.